All right, ladies and gentlemen, we have a request to do a boiling point, put the boiling points in order question, fall 14, test 1, part 4, question 3. And we have a bunch of molecules. And before I start, I like to do a count of the number of heavy atoms. And what are heavy atoms? Here, nitrogen and carbon and oxygen are the big three heavy. They're heavier than hydrogen. So I'll do heavy atoms in red. Heavy atoms, that's not red, in blue. So this one, 1, 2, 3, 4, and 2 oxygen, 6. Next one, 2, 3, 4, 5, 6. Next one, they might all be 6. 1, 2, 3, 4, 5, 6. Oh. Okay, now I hope that you realize even though IV is bigger than the first 3, they all have substantially stronger intermolecular forces available. So, especially number 1. Carboxylic acids are top dog in this course for intermolecular forces because they have hydrogen bonding through the OH, and the carbonyl can accept a hydrogen bond from another molecule. So it's got double hydrogen bond. So I'm never going to pick a London only over something similar in size with stronger forces. And this is an aldehyde that's got a polar covalent bond in it. So that's dipole-dipole, right? So my short forms for the answer are DD for dipole-dipole, L for London only. I'm going to use these short forms in my answer. If you choose to do the same thing and you did not write down that DD stands for dipole-dipole, I'm going to take some points off. You're not clear. DD is just random, people. But if you define it, it's not random. And HB is hydrogen bonding. Now I can use those instead of all that writing. Okay. So this is a carboxylic acid. Carbox acid. Anybody know what the second one is? Yeah. Aldehyde. Can I just go ald? No, I better go aldehyde. You guys are just learning. And it might not be clear, but this has to be a ketone. Or else you'll have charges and triple bonds to oxygen, and it won't work. You can't put the O in the middle. You can't make it work if you try that. So it's a ketone. That has DD, ketones, and so do aldehydes. DD. Sorry, it's a bit of a mess. And of course, the left of the screen is a dead area on the screen. And HB, right? And that's our strongest HB. You can go ahead and just go like this. And just say the one has the most extensive HB. That's why it's number 1 there. And we got an alkane there. And the next one, how many heavy atoms? 1, 2, 3, 4, 5, 6, 7, 8. Now, just between these two, IV and V, same intermolecular forces, correct? Just LO or just L? L, L. This is the only time you look at branching. See, they must have, first, same intermolecular forces. Second, same approximate mass. And we've matched that too, haven't we, with the number of heavy atoms. So then you're going to go with the one that's branched, being what, higher or lower forces? Remember, branching is like making it in a ball, and you can't get balls as close to each other as sheets, flat sheets. Remember that? So it's going to lower the branching in V is going to lower the intermolecular forces compared to IV. And I'll just say that this is just an IV versus V discussion. IV versus V. Branching causes London to go down. Isn't that's just as good as a sentence to me? Branching causes London to go down. And what's that going to do to the BP? If it's got less forces holding molecules together, you don't have to put as much heat in to get them apart from each other, right? Isn't that what boiling is? Yeah. So BP down. So the only conclusion from that is 5 is less than 4. We don't know. They're probably at the beginning, right? 7 is competing with them, but 6 is not. How many heavy atoms in 6? I think it's back to 6. And 1, 2, 3, 4, 5, 6 in the next one. But this one has HB. And this one, a tertiary amine, does not have any hydrogen bonding. It doesn't even really have a polar bond to start with. C and N is borderline polar, and there's 3 of them in different directions, canceling each other almost. Treat tertiary amines just like alkanes. Just write that down. Treat a tertiary amine just like an alkane. Okay? And that's just al. So in my alkane, my L category, I am now circling it in light pink because I know the order of these 3. So IV versus V versus VII. Whoa, sorry about that. Need to see him. Versus VII. There's a teeny bit of branching in VII. Stick figures will show it. Stick figures for VII is 2 methyls on a nitrogen, goes to CH2 once, twice, 3 times. Stick figures on the first, on IV, just 8 in a row, right? 2, 4, 6, 8. Stick figures on V is, goes to a second carbon with 2 methyls, goes to CH2, goes to C with 2 methyls. All right? So which of these 2 pictures, V or VII, does it look like there's a teeny bit more branching? Just count branches. 1, 2, 3. Count branches. 1. So we can be a little more specific on this. The most branched was V, and VII only had 1 branch. And the unbranched was IV. Extensive branch. One branch. There you go. And those are going to be the first 3. V less than VII less than IV. And after that, we're into H bonding, dipoles. They'll be before H bonding, correct? We have dipole number 1, and I didn't write it down. Yes, I did. It's on the left. Make it smaller. There you go. DD. Which of the 2 dipoles is going to show up first? Aldehyde's going to be a little better than a ketone. Pictures will say it again. We'll do 2. Picture for 2. Oh, it's got a branch too. Oh. Sorry, I just noticed there's a branch on this thing. Yeah. And then go CH. We got CH. Go to CH2. Go to C with an aldehyde. And 1, 2, 3. CH3 once, twice ketone. I will accept two answers here. I mean, the oxygen here is in the middle, which looks like a branch, right? I mean, it's an atom sticking off the chain. It's not a small atom. And this has an atom here off the chain, just one atom off the chain. They're almost the same. Now, if you think this looks a little more branched than this, I might give it to you because a methyl's a little bigger than an O. It's got a C with 3 H's on it. But I'm not going to be that picky with the grading of those two particular ones because they're very similar. Same mass, same forces, right? Same mass, same forces, roughly the same branching. And I'm going to change this. I'm going to do it like this. In green, not green, purple. I'm just going to do it like this. Get rid of the less than sign there and say 2, roughly the same as 3. And I think we just have the amine left. And that would be Bi. And we just say weaker H bonding. Weaker HB than 1. Lower electronegativity is the reason. It's nitrogen versus oxygen. And my explain is see below and above. Everything but the box here. Sorry. I think we covered everything we need to cover. We should mention something about London only. Yeah. Those 3 were London only. Lower forces. Okay. And that's that. We'll stop it. End it.